The raised cosine filter is a filter frequently used for pulse shaping and digital modulation due to its ability to minimize inter-symbol interference. Its name stems from the fact that the non-zero portion of the frequency spectrum of its simplest form is a cosine function, raised up to sit above the axis. Mathematical description. The raised cosine filter is an implementation of a low-pass Nyquist filter, that is, one that has the property of vestigial symmetry. This means that its spectrum exhibits odd symmetry about, where is the symbol period of the communications system. Its frequency domain description is a piecewise function, given by, or in terms of Haver cosines, 4, and characterized by two values: the roll-off factor, and the reciprocal of the symbol rate. The impulse response of such a filter is given by, in terms of the normalized sinc function, equals roll-off factor equals, the roll-off factor, is a measure of the excess bandwidth of the filter, that is the bandwidth occupied beyond the Nyquist bandwidth of some authors' use. If we denote the excess bandwidth as, then, where is the symbol rate? The graph shows the amplitude response as is varied between 0 and 1, and the corresponding effect on the impulse response. As can be seen, the time domain ripple level increases as decreases. This shows that the excess bandwidth of the filter can be reduced, but only at the expense of an elongated impulse response. As approaches 0, the roll-off zone becomes infinitesimally narrow, hence, where is the rectangular function, so the impulse response approaches. Hence, it converges to an ideal or brick wall filter in this case. When, the non-zero portion of the spectrum is a pure raised cosine, leading to this simplification. Or equals bandwidth equals, the bandwidth of a raised cosine filter is most commonly defined as the width of the non-zero portion of its spectrum, that is, 0.